good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Livinda with the introduction to differentiation. So we have our x or y plane right here, and then we have a curve. So just think of a curve, alright? So you think of a curve, maybe it is a decreasing one. What do I mean decreasing? It was up, it's going down. So it's like a decreasing curve like that. Okay, so let's draw it like this. It's a decreasing one. Differentiation. You can find the gradient. The gradient is the slope. Under coordinate geometry, learn about gradient. Okay, now differentiation helps you to find the slope of this curve at any point. Just like in coordinate geometry, you can find the gradient of a slope at any point, right? Whether it's there, there. You recognize that if it's a straight line, the gradient is the same. Now for a curve is not a straight line. So the gradient that you would find here would be different from the gradient you would find there, and there, because it is not a straight line. So if you want to find the gradient of a point, for example here, what we do is we draw a straight line touching that particular point only. So it's just a straight line that is going to touch that point only. Okay? So that straight line is not looking good. And let me try to use the ruler. Okay. So that's your straight line. And then your curve is looking like that. Your dot is right there. Alright. So let me just draw it like this. Okay. So this straight line is touching that particular curve at that point only. This straight line that we draw is called the tangent. So this tangent, the way we do it is that we find if you find the gradient of this tangent line, it means you're finding the gradient of this particular point at the curve. That's what we do in under calculus differentiation. So if you find the gradient of this tangent line, using the gradient formula, the y step, m is equal to y step over the x step, which simply means you are saying m is equal to the y over the x part, like that. So if you find the gradient using this formula of this line, it means that now you know, because this line is only touching the curve at that point only, it means you have found the gradient of that point. And that's what we are going to use to find this is the basis behind the differentiation. You find the gradient. Okay. So it means you find the gradient of that point. Thank you so much for watching this video. This has been Cornelius Livinda, and bye-bye.